Imagine a news bulletin, not from today but from 3.5 billion years in the past. The headline: Catastrophic planetary event strikes Mars. The planet's molten core, once generating a protective magnetic shield, has sputtered and died. Without this invisible force field, Mars is defenseless against the solar wind. Charged particles from the sun begin to strip away the atmosphere, molecule by molecule. The sky thins, pressure drops, and the thick, warm air that once held clouds is lost. Water, once flowing in rivers and seas, begins to boil away or freeze, vanishing into space or locking itself in ice. The world is being flash frozen and desiccated at the same time. The dream of a second living world in our solar system fades. This isn't science fiction. This is the story written in the rocks and dust of Mars today. Every crater and dried-up riverbed is a clue to this ancient catastrophe. By studying Mars, we act as cosmic detectives, piecing together the evidence of this planetary crime. We search for what happened to the water, and if anything lived in it before it vanished. The story of Mars is a cautionary tale, a reminder of the delicate balance that allows a planet to thrive. And it's a story we're only just beginning to read. Let's rewind the clock 4 billion years. Mars was once a world of breathtaking beauty, not a cold, red desert. It had a thick carbon dioxide-rich atmosphere, creating a greenhouse effect that kept the planet warm enough for liquid water. Imagine standing on a Martian shore, gazing over a vast northern ocean, Oceanus Borealis. Rivers, wider than the Nile, carved through the highlands, feeding this ancient sea. Today, we see their dry, winding channels, fossilized fingerprints of a water-rich past. Mars had a full water cycle. Clouds, rain, maybe even snow on volcanic peaks. The sky might have been hazy butterscotch or pale blue at sunrise. Volcanoes, some of the largest in the solar system, were active, shaping the landscape. For a while, Mars and Earth were parallel worlds, both with volcanoes, atmospheres, and water. But their destinies diverged. Earth held onto its water and life. Mars lost almost everything. Understanding why is one of planetary science's greatest quests. The clues to this story of planetary life and death are waiting for us on that distant, rusty world. Mars's ancient beauty is gone, but its secrets remain. We study its rocks and valleys to learn what makes a planet habitable, and to understand how worlds can change forever. What went wrong? The loss of Mars's global magnetic field was the turning point. Earth's molten core creates a magnetic shield, deflecting the solar wind. Mars, smaller and cooling faster, lost its dynamo and its shield. The solar wind slammed directly into the Martian atmosphere, stripping it away over millions of years. As the atmosphere thinned, pressure dropped, liquid water could no longer exist. Oceans and rivers boiled away or sublimated, vanishing into space. Water vapor was broken apart by sunlight. Hydrogen escaped, lost forever. The surface, exposed to oxygen, began to rust, giving Mars its red color. The red planet isn't angry, it's rusty, a monument to lost water and lost potential. Mars's transformation was slow, but relentless. Its thick atmosphere and water cycle disappeared, leaving a frozen, oxidized relic. The story of Mars is a warning. Planetary protection is fragile. By studying how Mars lost its water, we learn what keeps a world alive, and what happens when its shield falls. Mars is a frozen reminder of what might have been. To understand Mars, we must look inside. Like Earth, Mars has a core, mantle, and crust. But the details matter. NASA's InSight lander revealed Mars has a large liquid iron core, mixed with lighter elements. The core is less dense than expected, a clue to Mars's formation. Surrounding it is a thick mantle of silicate rock, once hot and convecting, driving ancient volcanic activity. But Mars cooled quickly. Today, its mantle is much less active. The crust is thicker than Earth's, especially in the southern highlands. This thick, iron-rich crust preserves Mars's ancient history. Craters billions of years old remain visible. Unlike Earth, Mars has no plate tectonics. Its surface is a static, frozen landscape. Comparing Mars and Earth is like comparing siblings who took different paths. Earth's dynamic interior keeps it geologically alive. Mars's heart grew quiet. By studying Mars's interior, we learn what makes a planet habitable, and what happens when its internal engine runs out of fuel. Mars's quiet heart is a lesson in planetary fate. If you think Earth's Grand Canyon is impressive, meet Valles Marineris. This colossal canyon system stretches over 4,000 kilometers across Mars's equator, wider than the continental US. At its deepest, it plunges 7 kilometers down. Unlike Earth's canyons, Valles Marineris wasn't carved by water, but by tectonic forces. The nearby Tharsis Bulge swelled with magma, stretching and cracking the crust. Valles Marineris is a planetary scar, a record of immense geological forces. To the west lies Noctis Labyrinthus, a maze of intersecting canyons and fractured terrain. Further east, linear chasms like Coprates Chasma reveal layered canyon walls, pages of Martian history. These layers show landslides, different rocks, and hints of ancient lakebeds. Exploring Valles Marineris is a top priority for future missions. Rovers or helicopters could sample canyon walls, search for water ice, and look for signs of past life. Valles Marineris is more than a scar. It's a gateway to Mars's secrets. Its depths hold clues to the forces that shape the red planet, and perhaps to the story of life itself. Mars exploration isn't just from orbit. We've sent robotic geologists to the surface. Curiosity rover landed in Gale Crater, a 154-kilometer-wide basin with a central mountain, Mount Sharp. The mountain's layers are a history book of Mars, from its watery past to its dry present. Curiosity's mission. Did Mars ever have the right conditions for life? The answer? Yes. Drilling into rocks, Curiosity found clay minerals formed in fresh water. Evidence of ancient streambeds and a long-lasting lake emerged. The rover detected complex organic molecules, the building blocks of life. Curiosity also acts as a weather station, measuring temperature swings, radiation, and mysterious methane plumes. The source of methane remains a mystery, geological or biological. Every rock Curiosity studies adds to Mars's story, a once habitable world. Its journey continues, revealing new chapters with every discovery. Mars's ancient lakebeds may hold the answers to life's greatest questions. NASA's Perseverance rover landed in Jezero Crater, a site once home to a deep lake and a magnificent river delta. River deltas on Earth preserve signs of life. Could Jezero's delta do the same? Perseverance's mission searched for signs of ancient microbial life. Its instruments analyze rocks for biosignatures, evidence of life's handiwork. The rover drills core samples, sealing them for a future return to Earth. Perseverance brought a companion, Ingenuity, a tiny helicopter. Against the odds, Ingenuity flew in Mars's thin air, becoming an aerial scout. Together they explore the delta, mapping terrain and finding organic molecules in the rocks. Perseverance has found rocks altered by water, confirming long-term habitability. The combination of ground and aerial exploration is revolutionizing planetary science. Jezero's secrets may bring us closer to answering, are we alone? Mars has 2 tiny moons, Phobos and Deimos, Fear and Dread. They're small, lumpy, and likely captured asteroids, not true moons. Phobos is just 22 kilometers across, Deimos only 12. Their dark, irregular shapes and carbon-rich composition hint at their origins in the asteroid belt. Phobos orbits incredibly close, whipping around Mars in just over 7 hours, rising in the west, setting in the east, multiple times a day. Deimos is further out, orbiting every 30 hours. Phobos is in a death spiral, inching closer to Mars each century. In 50 million years, it will crash into Mars or break apart, forming a temporary ring. Deimos, meanwhile, is drifting away, destined to escape Mars's gravity. These moons are relics of cosmic chance, captured wanderers with dramatic futures. Their stories add another layer to Mars's complex history. The story of Mars is a tale of 2 planets, one thriving, one frozen. Mars is a cosmic laboratory teaching us what makes a planet habitable. Its mysteries drive our exploration. Did life ever arise there? Where did the water go? Could future explorers tap into hidden ice? Every discovery on Mars deepens our appreciation for Earth's fragility. You don't need to be a scientist to join this journey. Sharing images, reading discoveries, or simply gazing at Mars connects us all. Citizen science lets anyone help explore the red planet. The quest for Mars is a fundamentally human endeavor. Curiosity, exploration, and wonder. One day, human footprints will join rover tracks on Martian soil, a milestone for all humanity. Mars is waiting, its secrets buried beneath the dust. It's up to us, the curious inhabitants of Earth, to uncover them.